There are a lot of capacitance in MOSFET, which means a parasitic capacitance. For example, there are a fringing capacitor, which inner fringing capacitor and outer fringe. Also, there is a overlap capacitance, and we have a oxide capacitance. And there is a junction capacitance. It is because of a body and substrate, substrate and drain, and substrate and source are PN junctions each other. So we're gonna measure these capacitance each other using superpositions, using a split CV measurement. So in here, there is a gate. We're gonna bias it with high voltage, and in the source and drain and body, we're gonna bias with lower voltage. In accumulation state, there is only a oxide capacitance and depletion, but there is a channel to be bias it. So there is no voltage drop on depletion capacitance. Secondly, there is a depletion region. In depletion regions, there are a oxide capacitance and the parallel connections between junction capacitance each other and depletion capacitance. And in inversion region, there is a electron channel. Similarly to accumulation stage, the total capacitance would be a oxide capacitance. So there is a total capacitance is a harmonic average to all these capacitors. So we're gonna change these combinations between biasing through a drain source or gate body. So here there is we're gonna bias it through gate and channel, which means we're gonna give a higher voltage to the gate, and the two source and drain channels, we're gonna give lower voltage and ground it on body. In accumulation stage, there is a whole channels induced. So a current flows through this source or drain, and the channel gate channel capacitance will be only exist in oxide capacitance. On depletion region, also like which we calculated on the total capacitance, there will be a combinations with oxide capacitance and junction capacitance. Because of body has grounded, there will be no voltage drop on depletion capacitance. Because of a junction capacitance are so small, those capacitance will be get dominant. Total capacitance will be very small. So, now we have a inversion stage. Similarly to accumulation stage, there will be a electron channel. So there would be no voltage drop on depletion capacitance. So the gate channel capacitance would be capacitance of oxide. Now we're gonna get different combinations on biasing. So let's take a look at here. We give a higher voltage on gate and a lower voltage on body. So in here, the whole channels are induced by the accumulation stage. So there will be a oxide capacitance, also a depletion capacitance. So, and the depletion region, there is a all kind of a capacitance would be exist. A oxide capacitance, junction capacitance, depletion capacitance. However, there is no voltage drop between a channel because we grounded source and drain. So total ground body capacitance would be in here. But the depletion capacitance is dominant because the capacitance is defined with a capacitor's length between the electrodes. So as depletion width gets shortened, the capacitance will be larger. But however, in depletion stage, there will be get depletion width will be longer. So the total capacitors also gets lower. And then a inversion state, there will be like similar as accumulation stage. So total capacitors will be a dependent on depletion capacitor. So by using those measurements, we're gonna draw a CV characteristics with gate body capacitance and gate channel capacitance. As we look at here, at accumulations and depletion regions there are not constant because at gate body capacitance there will be no current between channels or source or drain. So a depletion capacitance would be affected to the accumulation region. And then on depletion side, through the flat band voltage would be the same effect as at accumulation region. However, in depletion region, after the threshold voltage, junction capacitors would be a dominant because they are so small. So on the threshold voltage, there will be almost zero capacitance. As we through the weak inversions and strong inversions, there will be constant oxide capacitance because at gate channel capacitance, when we measuring gate channel gate channel capacitance, we biased like here. So there is parallel with the line, electrical line between depletion capacitor. So there is no effect to depletion capacitor. If we give bias to drain to source, then in accumulation stage would be also be constant